A new study finds that a mysterious ghost particle probably did not come from a black hole's meal after all. This is an animation of AT219 DSG by DESI Science Communication Lab. Tremendous amount of information. Look at this. The animation is amazing. It looks like a pot boiling over. Now, the high energy neutrino traced back to a violent encounter that took place between a black hole and a star, and it needs a different origin story, the new research finds. The analysis of radio waves emitted by the encounter, known as AT219 DSG, and this is what we're showing the animation of, has shown that it was fairly ordinary, at least as far back as black hole tearing apart a star goes. And that means that the event is not energetic enough to produce the neutrino months later, that the events were merely coincidental. Instead of seeing the bright jet of material needed for this, we see a fainter radio outflow material. This is what astronomer Kate Alexander explains. She's from Northwestern University. She said instead of a powerful fire hose, we see a soft wind. The death of a star by a black hole is not a neat, tidy process. When an errant star comes close enough to a black hole that is snared by the latter object's gravity, the colossal tidal force of the black hole, the product of its gravitational field, first stretches and then pulls the star so hard that it's torn apart. It's called the tidal disruption event, TDE. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. So this is what it would look like. A NASA image shows us. It's called the TDE. It releases a bright, brilliant flare of light, glowing brightly as half of the debris from the disintegrating star swirls into a disk around the black hole, generating immense heat and light before it's pulled inexorably beyond the event horizon. Then the other half of the debris gets flung out into space. That's a theory. Now, AT219 DGS, first detected April 9, 2019, was this type of an event from a galaxy 750 million light years away. X-ray and radio observations confirmed a supermassive black hole, 30 million times the mass of our sun, undergoing a TDE. And nearly 6 months later, October 1st, 2019, a neutrino called IC 19101A was detected at the Ice Cube neutrino detector in Antarctica, clocking in at a whopping energy level of over 200 tera-electrovolts. Neutrinos are called ghost particles, quote unquote. That's because their mass is almost zero. They travel at near light speed and they don't really interact with normal matter. To a neutrino, the universe would be all but incorporeal, and occasionally they do interact, and this is how Ice Cube works. When a neutrino interacts with the Antarctic ice, it can create a flash of light. With detectors tunneled deep under the ice, those flashes really stand out. And based on characteristics such as how the light propagates and how bright it is, scientists can work out the energy level of the neutrino and the direction from whence it came. IC 19101A came from the direction of AT219 DGS, the animation we're showing here, so closely that scientists calculate just a 0.2% chance that the neutrino and TDE were unrelated. So there are some significant issues raised by this. Astronomer Yvette Kendes, Center of Astrophysics, Harvard and Smithsonian, said, if this neutrino somehow came from AT219 DGS, it begs a question. Why have we not spotted neutrinos associated with supernova at this distance or closer? They are much more common and have the same energy velocity, she says. The research team led by Kendes used the Atacama Large Sub-Millimeter Array in Chile to observe this AT219 DGS for over 500 days in radio wavelengths and they found that the TDE continued to brighten in radio wavelengths for around 200 days, at which point it peaked and began to dim slowly. They also calculated the amount of energy in the TDE outflow, and it was about as much energy emitted by the sun over 30 million years. Can you imagine? That's pretty standard for TDE, as well as type 1b and type 1c supernova. In order to produce a neutrino as energetic as 1c 19101a, the energy of the outflow would need to have been around 1,000 times greater. And it also would need to have had a strange geometry, which AT219DGS that we see here animated outflow did not. It didn't have a strange geometry. It was pretty weak. Now, AT219DGS is really rather ordinary after all. Since IC 19101A is not ordinary, that means that a new explanation has to be found. But there's a lot we still don't know about neutrinos, and TDEs for that matter, so it means that AT219DGS is going to continue being of interest and a mystery. We're probably going to check out on this once again. Senda said this particular black hole is still feeding. This is published on Astrophysical Journal Creative Commons, and it's on Science Alert by Michael Starr. Please leave your comments. Thank you for your support.